So, which ball will land further? Well, for like most of you guys said ball two, but like your explanation wasn't like really all that great. So, does anyone want to try to explain? Jack, do you want to try to explain why ball two would land
Okay, yeah,
further?
I can. So ball one is kicked from ground level, and since ball two is kicked off like with an elevation already, it gets like greater air time, so it starts off like high, so then it travels further until it reaches the highest point, and then it starts decreasing. But then when it reaches its highest point is further than ball one, since it's kicked off with a higher elevations. So that it has more air time using having negative velocity.
Yeah, that's correct. So some of you guys just said it would have like greater velocity. But like what I was looking for was just like that it would have greater air time. Because a greater elevation correlates with having like having greater velocity, and then when it reaches the ground, and when it has greater velocity at this point, it would take more time to reach that. So then it would have more air time to go for its horizontal velocity. So if your answer includes something with like time, then it probably would have accepted it. Okay. I have more space for this one. So yeah, a girl kicks an apple off a hill at 20 meters per second at an angle of 30 degrees. The hill is 49 meters tall. How far does the apple land? So looks like this. And then it's like 30 degrees. And then this is like 20 meters per second. And then it goes to some point here, and then it falls all the way down. So we're going to calculate the time separately since we want to know how much air time it has first, right? So we're going to calculate how much time it takes to get to this point, and then how much time it takes for it to fall down to the ground here separately. So first off, we just find Vy, the vertical velocity, and I think I'm going to type this actually. So Vy equals 20 meters per second times sin 30, which is like 10 meters per second, right? So then we want to find how much time that takes using this equation. And then plugging everything in, we just get 10 divided by 9.8, which is t equals 1.02 seconds. So the time it takes to get up here is 1.02 seconds. But now we want to calculate how much time it takes to get here. So first we need to calculate the height of this. And this is 49 meters, right? So to calculate the height of how far it goes up, we can use the time independent equation. So Vf squared equals Vi squared plus 2a delta x. And we note that plugging it in, Vf is 0, Vi is 10, and a is negative 9.8. You should get 10 squared divided by 2 times 9.8. So is this right? So Vf is 0. So 0 squared equals 10 squared plus 2 times negative 9.8 times delta x. And that's like negative 100 divided by 2 times 9.8. So, and then delta x ends up being 5.1 meters. That's right, I think. Yeah. So then this total height here, so this height here is 51. This height here is 5.1 meters. So then you want to like add these two up to find the total height. So then that just equals like 49 plus 5.1. That should equal like 54.1. So 54.1 meters is the total, like this total is this total right here. And then using this, we can plug this back into our time independent equation to get the final velocity at this point. So I will move it here. df squared. And then we get that v final is equal to like, because v initial is 0, right? It's like just basically square root 2a delta x. And we get that times after plugging into your calculator, you should get 32.5 meters per second. So that's v final. And then we just want to calculate the time it takes, which is 32.5 meters per second divided by 9.8 meters per second squared. So that just ends up being 3.32 seconds. So the time it takes to get down here is 3.32 seconds. So then we can just add these two values up to get its total air time. And we get that like its total air time is 4.34 seconds. And then we can find the horizontal velocity now. So Ex equals 20 meters per second times cos 30, which equals like 10 square root 3. And then so basically we can then multiply this total air time by this velocity. So 4.34 times 10 square root 3, which is 75.2 meters. Does everyone understand that? Questions on how we get here? And how we get here. Does anyone need time to copy this down or anything? Just message me if you need time to copy this down. Okay. Now I think we'll go over like the problems that we did not get to last class. So It's okay, Jack. Physics is hard. So now, I think you guys know you just have problems now. Um, okay, go ahead and try this. Oh, private message me your answers, by the way, when you get it. Yeah, if it rolls off the table at 3 meters per second, it just means its angle is 0, and so it doesn't have any vertical velocity at all. So vertical velocity is 0 meters per second. Basically. Yeah, 9 meters tall just means how high the elevation is. Yeah. Yeah, Ethan, that's correct. For those who don't know where to start, first start by getting the final velocity it takes to get here. Like calculate velocity when it hits the ground, like that, right? What is v final here when right before it hits when it hits the ground? And the equation you use to find this is vf squared equals vi plus 2a delta x. So start by finding the final velocity. And after you find the final velocity, just calculate the time using this. And then after you calculate the time, multiply the horizontal velocity by time. And then you should get the delta x. You should get like how far. Actually, I'll just type your answer. What's delta x? Okay, Steven. So delta x is the height here, 9 meters. What you're dealing with in these two equation is just the vertical velocity. Vertical velocity and like vertical components, meaning like the height like this, which is like 9 meters. So here delta x would equal to 9 meters. And when you're calculating v final and v initial, you're also using the vertical velocity. And acceleration also correlates with like vertical component, which is negative 9.8 meters per second squared, because that's g, right? And then same here for calculating the time. Yeah, Jamina, that's correct. For everyone else who didn't answer yet, are you guys still calculating? Just like tell me in chat. Or if you're stuck, also tell me in chat. Or just unmute yourself. No one's messing. I'm okay, so I don't know if you guys are still just calculating. Like guys, please just tell me if you guys are still calculating or if you're stuck. Just in chat. Sure, that's correct. Jack, you're stuck. Okay, what about everyone else? Like, who else hasn't answered? Like Vanessa, Steven, Helen, Aaron, the other Aaron. Okay, so you're stuck. Okay, what else? Okay. Okay, I think I'll just go. Wait, okay. Jack, what part of you are you stuck on? Jack, are you there? You don't know? Okay, I wrote down the steps, so maybe you can go ahead and try. Okay, well, um, I don't know. It's not a very good answer if I ask you what you're stuck on. Uh, Helen, what part are you stuck on? Do you not know how to get started, or do you not know how to get final velocity here, or which part are you stuck on?
So I know how to do the problem. I'm just not sure if 9 meters is the delta x or the final velocity, initial velocity.
9 meters tall. The table is 9 meters tall.
Yeah.
You're not sure if that's velocity or delta x?
Yeah.
Okay, guys. I don't know if I said this already, but if you see meters per second, that correlates with velocity. Meters per second is like usually velocity. It is basically always velocity and speed. You can't measure displacement and acceleration with meters per second. Okay, meters is always like distance or something like delta x or something, because you can't measure speed with meters, right? Meters is literally the, oh my god, meters is like how tall something is. Like if I say this is like 3 meters, I don't even know how much this is like some meter tall, right? I can't measure this distance in meters per second or anything. Yeah, and similarly, I can't say this is like 3 meters per second tall because meters per second is like how much distance you travel in like 1 second, right? I can't say this is 3 meters per second because this is like how tall, right? You can't measure it like that. It's not the right units. So, and then meters per second squared is just acceleration. This you guys should just like memorize at this point, memorize this. Memorize. Okay. Steven, yeah, V final is that. Helen, you want to square root that, I think. Wait, actually, no, Steven, no, that's not right. Okay, so here, let me walk you guys through this. So we're dealing here, when we're dealing with this, we are only dealing with the y component, right? Right, Steven? So 3 meters per second is not the initial velocity for the y component. I don't know if that's right. I don't know. Okay. 3 meters per second is Vx. Okay, wait, let me annotate this. So 3 meters per second here is equal to Vx, right? Vy is equal to 0 meters per second. Remember, because it's not going down, right? It's not like this object is like, it would have vertical velocity if it were like angled. If it were like angled like this or like this, then it would like have vertical velocity, but no, it's just rolling down this way, right? So its vertical velocity would be 0 meters per second. So like to find our final velocity here, we have the equation Vf squared equals Vi squared plus 2a delta x. So we know that V final, we want to know V final, right? V initial is 0 meters per second because we're only talking about the vertical velocity here. And A is gravity. So, and then delta x is just 9. So then we find that V final is like square root of 2 times 9.8 times 9. And you should get, that's like, this is like square root of 176.4. So then you'll get that V final is 13.28 meters per second. So when you're calculating like final velocity and like to get like time, we're only dealing with air time. And the only thing that gives air time is vertical velocity. So we don't care about like this 3 meters per second here. So it takes 13.28 meters per second, or here V final is 13.28 meters per second, right? So we want to know how much time it takes to get down there, because that's how much that'll give us the air time, right? So we do V final equals V initial plus AT. And similarly here, V initial is 0 meters per second because it doesn't have any vertical velocity. So then we divide, you'll eventually just get like that divided by 9.8, and then you'll get that like time is equal to 1.35 seconds, meaning it takes 1.35 seconds to hit this ground here. So that's how much air time it'll have, right? So that's how much time it has to travel using its horizontal velocity. So then we multiply its horizontal, now we only care about horizontal velocity. So we multiply its horizontal velocity, 3 meters per second, times 1.35 seconds to get like 4.06 seconds. I mean meters, not seconds. God, wait, hold on. 4.06 meters. Does everyone understand that? Jack, do you get it now? Jack, Steven, Aaron, Vanessa. Okay, so if I asked you guys to do a similar problem, would you guys know how to do it? Yes? Yes? Okay, probably. Okay, I guess you guys just have to like solve it. Okay, right now we can have a 5-minute break, so come back at like 11:38. Okay, guys, start coming back and turning on your cameras, please. Okay, so I think we'll continue. Okay, so this is basically kind of similar to our last problem, except you have to do the steps in backward, kind of. Because it's not asking for how far it lands, but now how tall the table is. So, a little different. Basically, it just looks like 5 meters per second, and then it lands 20 meters away. So like this. And then it wants to know this height. Yeah, Stephen, T is 4. Okay, Aaron. So I will kind of explain how you do this. Actually, guys, you guys just want me to like solve the problem to show you guys. But I feel like you guys also need to like practice how to do it because that's the only way. Is table 4? No. So basically, what you first want to do is find the air time, which is really easy because we can tell the air time is 4 seconds by just dividing 20 meters by 5. So like t equals 4 seconds, right? T equals 4 seconds, meaning it takes 4 seconds to reach here. And so if like it has 4 seconds, right? And so basically then we want to calculate v final. This is vertical. Now we're doing everything in seconds. So we don't care about dividing. So we want to use this equation to find v final. We have the initial, which is 0 meters per second here. Vi equals 0. A equals 9.8 meters per second squared, because that's gravity. And then t equals 4 seconds, right? So then just find v final, right? You're gonna get v final equals, just say, for example, we can just assume that v final equals x meters per second, right? After that, we can plug this v final square into this, v final into this equation. And delta x here represents this height, right? So then we just end up doing x meters per second squared equals like 0 meters per second squared, which is just 0 squared, because that's the initial for vertical, plus 2 times 9.8 meters per second squared. And delta x. So then just find delta x. And because I've given you all the equations, I feel like all you guys should have to do is plug it into the calculator, which and like expect like half of you to answer at least. Is V final 2 times 9? No, why would V final be that? Yeah, Steven, yeah, 4 times 9.8. Yeah, Steven, that's correct. That's what V final would be. Yeah, Steven, that's correct. Yeah, Jamina, that's correct. Are you guys still calculating? So all you guys have to do is plug in the numbers into the calculator. Yeah, Shuri, that's correct. Aaron, how did you get that? Wait, hold on. Let me differentiate between Aaron's. Where's the other Aaron? Okay, the Aaron without the last name. How did you get that? Aaron, are you there? Okay, he's not responding. For the rest of you guys, are you guys stuck or something? Oh yeah. Oh, Ethan, that's correct as well. I missed your answer, sorry. Helen, Jack, Vanessa, the other Aaron. Are you guys still calculating? Okay. We're just waiting on you guys, so. Okay, calculator shouldn't take this long, honestly, though. But guys using a calculator or by hand? Because if you're doing it by hand, just type in the equation. Like Steven always types me in just the equation and I accept it. Wait, if you guys are doing it by hand, just type me the equation. Like the simplified equation, because that's what Jack always does and it's fine. And how'd you get 44 points? Okay, I think I'm just gonna. Okay, how are you guys getting these numbers? I'm super confused. Okay, guys, I'm gonna explain this again. You guys should pay attention. So from here, V final. We want V final here, right? Because this is the vertical velocity at V final right here, right? V final, V initial right here is 0, right? So it's just 0 plus acceleration, 9.8 meters per second squared, times time, which is 4 seconds. So then 9.8 times 4 is your final velocity. Also, meters per second squared, this is the second squared, not like this entire value squared, because acceleration is measured in meters per second squared, just like this is its units. It's not like, this is not equivalent to 9.8 squared meters per second. Like they're not equal. They're not the same thing. Like, I think I said that in the units thing, like just now, guys. So then this would end up equaling 39.2 meters per second, right? So this is V final equals 39.2 meters per second. And then when we plug this in, all we get is 9.2 meters per second. And then we square this is equal to 0 plus 2 times 9.8 meters per second squared times delta x. And then we just get delta x by square rooting, not square rooting, but basically just doing 39.2 meters per second squared divided by 2 times 9.8 meters per second squared. And if we just divide this, we get 78.4 meters. So delta x would equal 78.4. And also, when you simplify your equations, I said like before, you want to isolate delta x. You can't give me like, you can't give me this equation. If you want to give me an equation, give me this equation, because you're isolating delta x. Like this equals to delta x, right? You can't give me this equation. Just give me like this one. Okay. You can give me this answer or this answer. Either one's fine. So then this will equal 78.4. Questions? I feel like every time I ask for questions and no one says anything, and then like I move on to the next problem and you guys like don't know how to do it. So I'm not sure what to do about that. But like, if you have questions, just say out loud. I don't think anyone's gonna judge you for not knowing. Okay, so try this problem. And if you don't know how to do it, just message me and I'll tell you basically how to do it. Otherwise, you guys will not know how to do it for like, you guys won't know how to do it if you just don't ask, okay? Basically, this looks like 20 meters per second. And then this is actually, there's no height. What am I doing? So basically it just looks like this. And 20 meters per second. So first thing you want to do is split it up into Vy component and then Vx component. So what does Vy equal to and what does Vx equal to? So after calculating the vertical velocity, just use the vertical velocity to find the maximum height, which is this, right? x, and then it falls back down. Like that's like the motion. So everybody, could you just like type in what Vy would equal to? Just like the first step. Okay, yeah, Steven, that's both correct. Jamina, that's correct. Hey, everybody, just type in the answer to what is vertical velocity. And this is basically the first step. So like everybody should be able to like do it. And if you don't know, just tell me. Helen, that's correct. Shuri, that's correct. Okay, I want everybody to answer this. So like Jack, Vanessa, Aaron, other Aaron. What is exactly Vy? Vy is the vertical component. I think I explained this to you yesterday, Vanessa. You can like split this up into like this, basically. And like their total like sum would like kind of equal this. It's like a triangle. Vanessa, if you got it, then like just type in your answer, unless you're still unsure. And tell me. Ethan, that's correct. Okay, if you guys are not answering, yeah, okay, there. Just like say you're unsure how to start. Yeah, that saves time. So basically, remember what I told you, Vanessa, like just by definition, you can remember that to find this component here, just multiply this value by sine, remember? Remember how I told you sine was equal to opposite over hypotenuse? Equals O over H. And so this right here is opposite. So you can just do 20 meters per second times sin 37 to find Vy. And that's basically the first step. And then similarly for Vx, we can use the definition of cos equals adjacent over hypotenuse and find that the horizontal velocity is 20 meters per second times cos 37, which is Vx. Okay, I have not calculated that. But Vanessa, do you understand that? You think so? Which part do you not get? Yeah, Aaron, that's correct. If Vanessa, if you multiply it out in your equation in your calculator, what would you get? Yeah, I'm pretty sure that's the right horizontal. Okay, so now, okay, say now we have, this is our initial, so basically most of you guys got, if you multiply this out, you'll find that Vy is basically like 12.04 meters per second, right? So that's our V initial, basically, for whatever equation you want to use, right? And we know what is the velocity at maximum height? Just type it into chat. Trying to like drill this into you guys' heads. Yeah, okay. Got it. Aaron, that's correct. Guys, type what the final velocity at maximum height would be. So what is the velocity here? The vertical velocity here. Cherie, that's correct. Steven, that's correct. Guys, I should be getting more answers. Guys, what is the vertical velocity at maximum height? Anybody? Everybody should be answering this because I said this multiple times. Okay, but wait, Jamina, I'm not asking that. What is the vertical velocity at the highest point? Guys, you
Oh,
guys
I
should be
typed it
knowing.
in earlier, but I just wanted to
Oh, you
like,
did? Sorry.
yeah, I don't really understand how to go for like, knowing like V horizontal. So I am kind of
Oh,
stuck,
wait.
but
For V horizontal? Oh, no, I just asked you what the what the vertical velocity would be at maximum height. You guys don't need to do any calculation for this. It should be like,
yeah, I typed it in already.
you did? Oh wait. I'm very blind, sorry.